Okay, we're starting today with a more technical chapter, one in which we will have some mathematical formulas. Now, I will already warn you, you don't need to know the mathematical formulas at the exam, but I would like you to understand the underlying concepts. That's because the concepts we will be speaking about are concepts that are really absolutely fundamental, absolutely basic for understanding how scientists model systems. Any science that makes predictions in the sense that it describes a system that changes will use these concepts. So this will be the concept of a model, a state space, a dynamic system, and then in a later stage we will go to the more complex concept of entropy, which is also very basic for the philosophy for understanding it. But let's start with the concept of a model. So a model is a simplified representation of a system. So a very basic example of a model is you could have a doll that represents a baby. Of course, that doll is not at all like a baby internally, but outside the doll may look like a baby, which means that you can make a doll that is more or less the right size and the right shape and the right weight of a baby. Why would you do that? Maybe if you want to train some nurses to handle babies, it would be good to have a model of a baby in the form of a doll. So a model is more generally anything that represents some other thing, but where the model is much easier to deal with than the original thing. So another typical example of a model is a map. You can have a very complicated city like the city of London, which we here see on a satellite photo. And then you can make a map of that, and that map here is the map of the underground will do. You want to know what's going to happen with the system, what is going to happen by looking at each of the objects, each of the properties, and then that will be the later stage, what's happening over time. So if you want to understand what